We're excited to introduce Arya Hidayat, who's a developer in the open source for Metabase, and will be moderating our next panel, rather, on the future of cross-platform. So Arya, with that, please take it away.
Thank you so much, Elaine. I am super honored to be here on this beautiful and amazing day. We will be joined by a number of experts, and for the next 40 minutes or so, we'll be discussing numerous cross-platforms, front-end technologies, and the challenge and the opportunities thereof. Without further ado, we have Max, Aditi, Charles, and Bran on our panel. Folks, would you be so kind to give a 60-second introduction of yourself? Let us know about your area or technology of expertise, platform coverage, programming language involved, and other relevant technical bits. Let's start with that order. Max, Aditi, Charles, and Brent.
I'm Max Lynch, co-founder and CEO of Ionic. We build Ionic Framework, which is a popular mobile development and increasingly a web development toolkit focused on enabling web developers, people who are traditionally used to building web apps, large front-end apps, and enabling them to become mobile developers with their existing skill set. So we focus exclusively on them. We're 100% all in on JavaScript. We love TypeScript, and Ionic powers upwards of 15% of the app stores today. So a lot of people using it. There's a ton of web developers out there, so that's really our niche.
I'm Charles Van Winkle with Adobe. I am in our digital video and audio group as part of Creative Cloud. So I'm a bit of an odd person out for a lot of this conference. I pretty much exclusively focus on native desktop, but our big desktop applications that have a 30-year history and have had to go through several evolutions of the platform and UI frameworks and how do you deal with cross-platform, it's still somewhat fitting, including that we've been doing some hybrid approaches to extensions where we still have a native C++ application that may even have some hand-rolled assembly or some GPU or other compiler or processor intrinsics. But we also have in some panels the Chrome engine running and feeding up UI and doing interaction in the same runtime.
Aditi, you want to go next?
Yeah, I'm Aditi Ravichandran, and I do a lot of React Native and GraphQL. I author courses for Pluralsight, mostly on GraphQL and React Native as well. And I've been doing React Native for the last 4 or 5 years and work for a startup here in Kansas City and also do some independent consulting. So happy to be here.
All right, Brent.
Hi, I'm Brent Randall, calling in from Los Angeles. I work at Riot Games, where we make a number of video games, including League of Legends. I work on the project Valorant at Riot. We ship to Windows for our client application and Linux for our server-side application. Development is primarily in C++, native, and we use Epic's Unreal Engine as kind of a framework to build our game on top of.
All right, so as David mentioned in his keynote this morning, a very common theme among these different cross-platform application framework is the prevalence and emerging use of JavaScript as the programming language. Maybe the first topic will be similar to what Ben mentioned earlier. Does language matter at all? Because JavaScript is so popular, is it a good thing or bad thing? What about Rust and WebAssembly? And there's a Dart with Flutter, Compose, Kotlin. There's also another generation of language, and Elm, Rescript, and ClojureScript, and who else knows that? What's your take on this? Maybe let's start with Charles and Brent first, and then I want to hear your opinions, Max and Aditi.
Well, I was actually thinking about the opposite problem in that our scripting language and extensibility that came to our desktop apps in the 90s was a different offshoot of ECMAScript than what JavaScript became. And we still have that in our apps today and have been having trouble shaking it. When I joined the company 15 years ago, we said this part was going to go away. And then it was going to be ActionScript because everything was about Flash during that era. Mm-hmm. And then that went away. And now the new sort of extensibility that we're looking at is pure JavaScript and TypeScript.
That seems that that's a good thing for you, at least in the context of Adobe application.
Yep.
What do you think, Brian?
Yeah, I'd say for games, like language definitely matters, especially given the type of games that like Riot Games wants to make that are highly competitive multiplayer games. We kind of get pigeonholed into doing kind of C++ so that we have direct access to the GPU and the CPU to like make our simulations run really fast. Like we're counting the number of milliseconds in our frames. So getting direct access to the hardware, either writing, custom assembly or, shaders or anything like that, we really need to make sure that we're close to the hardware for our performance needs. But at the same time, we do offer a scripting language as part of our workflow. That's a visual scripting language called Blueprint. It's provided by Unreal Engine, and we use that to kind of like definitely speed up content development, and it provides kind of a sandboxed areas for non-engineers to create, behaviors in the application in the game.
I hope you're not implying that JavaScript is slow, but we'll come back to that later. Max and
No,
Aditi from Ionic and React Native Cam, what do you think about this problem?
Yeah, I mean, I think JavaScript is popular for a few reasons. For one, it was kind of the most accessible, the language for the most accessible app development platform out there, which is the browser. But I think what it's turned into is just a generally satisfying and enjoyable language. So, my background is computer science. So I've written, used pretty much every language that's popular. And I just keep coming back to JavaScript, and especially modern JS with TypeScript, because it's just so productive. And I'm in the situation where I'm building apps that aren't necessarily needing to optimize down to the bare metal. I'm focused on functionality, business value, all that stuff. And there's just no, to me, for my needs, like there's no competition when it comes to what you can do with JavaScript in that sense. And I think, our ecosystem is focused a lot on web developers. Many of them are new to development in general, and they find JavaScript relatively more accessible than some of the other options. So I'm thrilled with it. I think I'm less experienced with WebAssembly. I think we're seeing a lot of interesting early applications of that. It's still really early, but one thing I've been kind of tracking is assembly script. I think that's what it's called, which is essentially like a very constrained TypeScript, a version of TypeScript that compiles down to WebAssembly. So I think if anything is going to appeal to our community, it's going to be something like that, as opposed to something like Rust or another language.
Aditi, what's your take on this?
I agree with Max, because I think using JavaScript along with TypeScript is super productive. And even in startup environments, it's easier to find talent that is, driven towards JavaScript than other languages, which is kind of why we pick React Native as well, because it's React and coded in JavaScript. So it's just easier to find talent. A lot of people like modern JavaScript, and the developer experience itself is pretty good. So, yep, it definitely appeals to me a lot.
I want to touch on something that I think very fascinating here, because you guys are mentioning about the developer productivity, easier to get talents, and so on and so forth. Seems that the discussion about language is just a subset of the discussion about the general topic, and that is a trade-off, right? What kind of trade-off you want to make to build certain apps? Now, there's a lot of frameworks out there, and David also mentioned the way Airbnb and Shopify treat React Native differently. And also, Electron seems to be polarizing. Some people likes application built with Electron. Some other people hates the fact that Electron consumes a lot of memory. If someone wants to build a cross-platform apps these days, obviously depending on covering mobile, desktop, and games and consoles, what do you think the trade-off that they need to pay attention to? Maybe let's start with Aditi and Max, and then Charles and Brent this time.
So as you mentioned, Airbnb and Shopify had completely different experiences with React Native. It just depends on what kind of application we're building. Is it going to be a standalone app, or is this going to be a native app that needs to also have some, cross-platform abilities with hybrid models? So I think that's where Airbnb and Shopify were differing. Airbnb had a lot of native developers, and they already had a native application. And React Native also was quite immature. This was probably a couple of years ago versus now, where it's come a long way. So I think with respect to trade-offs, like for example, in in my experience, we had a lot of cost constraints to build our application. So we didn't have enough, in terms of building two teams with both iOS developers and native Android developers. So we had to cut down on cost, and it definitely made sense to go for a cross-platform application. And we're not intense a gaming app or anything like that. So our performance didn't have to be top notch either. So we were building UI for simple workflows. And at that time, 4 or 5 years ago, React Native had just come out, and we thought, why not? Why not use React Native? So I would say trade-offs depend on, are you like focusing on just one base? Is this heavily iOS users, or just you want to build an Android application? So in that case, you would rather do native. But with cross-platform, and if you have more talent on JavaScript, I think you could pick something like Ionic or React Native in that case.
Max, what's your perspective?
Yeah, I would, to add on that, I think it's really all about people at the end of the day. When we started Ionic, it was really because we saw a type of developer that wasn't being served by the kind of the native mobile development ecosystem. Companies were not really they didn't take the idea that you could build quality mobile apps using web technologies seriously. So since then, what we've seen is obviously there's so many web developers out there. And the thing is, like, they're fully invested in being web developers. They want to build web apps. They want to deploy things everywhere. They want to write server-side apps with Node.js. And they're not going anywhere. They're not switching to different languages or technologies. They really are all in on that. And so when you look at companies, like we cater to a lot of enterprise companies as a business. A lot of those teams have had a history of building and being successful, hiring web development teams, working on apps that are going to run on mobile, but also be deployed inside of an internal network. They're used to that. So it's really all about people at the end of the day. And I don't know intimately the details of the Airbnb and Shopify situation, but it just sounds like different people with different skills and different goals, and ultimately that's why we have such a rich diversity of options, because people have different values and different goals.
Charles, I'd like to hear your take, especially since some of the Adobe apps started off from the desktop platform, and then they start to appear as an application for phones and tablets.
Yeah, I think across the vast portfolio, I've seen a number of different approaches tried where you start with native on another end, and then you try to abstract to bring on another platform, or you try to go cross-platform up front. And most engineers, if they have 5 years, past those decision points, will always say it was always the wrong decision. But we have, in the group that I work in, products that started in the 90s, large cross-platform Mac and Win code base, went through the Motorola to Intel chip transition on Mac, now also going to the ARM transition on Mac right now. But a few years ago, we also ported the code base to iOS and also Android. And Android, to me, kind of feels like a Frankenstein solution to do the bridge between the Java and our C++ code base. But it's certainly a tough thing, and I think I agree with the other panelists that who your talent is can largely dictate what framework you have. So, I mean, within Adobe, there's certain groups that already have a lot of platform abstraction. So you just always go from the standpoint of, well, I already have abstraction, so I just plug in a new, shim on the bottom to that, to whatever the platform is. But there's a question in Slack from Kramer about Lua. We also have some products that would do C++, and then all of their front end is Lua, and they've built up a large tooling set, internal tooling set around that, like an entire Lua debugger and things like that. So that would be like Lightroom and Character Animator. And for Lightroom, that's allowed them to traverse different platforms easier. And I remember a certain situation where with the Surface Book, you could unplug the keyboard and then it's a tablet. Well, they were able to just simply swap out all of the Lua that they already have for iOS and Android and just have that be on Windows. And it was a pretty seamless experience. It's the exact same app just by unplugging the keyboard.
Fascinating. Brand, games are on a completely different world and you have to work closely with the game designer early on. What's your take on the different trade-off if someone wants to build games?
Yeah, I think with games, you really get two options. You kind of have a custom engine that you develop yourself in-house, or you use an existing framework or engine like Unreal Engine. I've had the benefit of my career working in both. On League of Legends, we did the custom approach, right? League of Legends is a custom engine. We started out only on Win32. And at some point, we decided we want to try to go to OSX. And that was quite the effort to go to our second platform, I guess, our first multi-platform world. And then with Valorant, we have kind of Unreal Engine, which allows us to ship on both Windows for client and Linux for server, and get a taste of like, okay, using an established engine that already ships to different platforms, how does that feel? And I don't know. I think in both cases, you can always see the grass is greener on the other side. I think I would echo Charles. Like you do it for 5 years and you look back and you're like, we made the wrong choices. But I do think that using an engine to try to like give you a leg up to start in a multi-platform world is hugely helpful. It doesn't solve all the problems like deployment. It doesn't do anything like that, but so in terms of like cross-platform, the development, there's that. And then I think there's like the staffing and the people side of it towards like, for our designers, for instance, they're not even engineers. Can we provide a platform for them to develop content and behaviors and code and logic without needing to know C++? And the answer is like, yes. Like on League of Legends, we used Lua. It's funny that Adobe uses the same, and on Unreal Engine, they provide Blueprints, which is like a visual scripting language. And providing those sandbox areas to develop a lot of the user-facing content in your game, I think is like a really powerful tool to kind of have like to try to get the best of both worlds. You have your C++ engineers working on the engine to try to like do things in the most efficient way, and you provide this like nicely wrapped sandboxed front end for your designers and your developers to work in that doesn't require them to really understand C++ at all.
While we're in that topic, I'd like to get one question from the audience before we jump into the next subtopic. What do you think about the company using different languages like Java, C# and Python with Vue.js for a big single project? Is it good or bad? So who wants to take this first?
I'll take it. The majority of the projects I work on are C++ top to bottom, with the exception of small shims that would be like Objective-C for native iOS, the native macOS, build systems in Python. But the homogeny of it helps where people can focus on different areas in their career over time. Or if you have a fire, you can have someone that can at least go, oh, I know how to debug this. I know which tool I need to do, and go ahead and do that. Otherwise, there's a wall of like, oh, that's that platform or that's that language, and I don't know what to do. So having it be homogeneous, it certainly helps if you have a large development team.
And there's a different layer for each platform, at least for the UI layer.
Yeah.
Well, like they said, right, every computer science problem can be solved with another layer of abstraction. Any quick comment from Aditi, Max, or Brent about that?
Yeah, I mean, I think you're always going to have, I don't know, that sounds like a large company problem, but we're in a small company. I would say it makes sense when you're at different layers. Like obviously front end is JavaScript, back end we use Python, but other teams might use something else. But if you had a lot of different languages in the same layer, I think that's where things get dicey. But obviously, if you're a massive company, there's probably no avoiding some of that. So you kind of just have to deal with it.
Yeah, and I would chime in on Valorant. We use a number of different languages. I think we're up to like 6 or 7 right now across our platform services and our game and things like that. So it does require you to be like far more flexible. But I agree that there is a cost. You want to use the right tool for the job, but at the same time, there is this cost in terms of flexibility or on-ramping to a different section of the code base or the product that comes with that.
The next, Aditi, go on.
I agree. This definitely is like a difference between large companies and smaller companies. For most of my projects, I would use React or React Native front end, and then we would use either Node or Go for the back end, and that's about it. But I worked for larger companies, and there are just all sorts of things, even within the front end, and it's hard to avoid because they probably just kept building on over the years, and things changed. So. Yeah.
The next theme that I want to bring up here is accessibility. I don't know how it applies to creative apps or games, but definitely important for, let's say, mobile apps, because you want to make sure your apps works with existing screen readers, voice command, and so on and so forth. Maybe I want to hear your perspective on this, Max and Aditi first.
Yeah, so we spend a lot of time on accessibility. Ionic Frameworks controls are all generally very accessible. We run in an interesting environment where we're running in a native environment, so we have access to all the native APIs and all that. But a lot of the app the users are building is in a web view because they're building a web app. They're web developers. They want to deploy that same web app to iOS and Android and also the web, progressive web apps, etc. So fortunately, operating systems are really good. Accessibility works really well across that barrier today. We have a number of customers who that, accessibility is kind of a very important, if not like a legal requirement. And so we're able to handle all that. So in terms of testing, I think we use a lot of the same testing tools you would use for typical web app for testing accessibility. It's not my area of expertise. I'm blanking on the name of them, but we kind of use the typical web development toolkit when we try to verify all that accessibility.
Yeah, on React Native 2, we have, similar to whatever Max was saying, we have the accessibility features that we can include within components. We can have accessibility labels and hints, and we could use the iOS screen readers or Android screen readers that come with the device itself. And it works out pretty good. It's not as elaborate as you would see with HTML, ARIA, and all of that stuff, but it is slowly evolving in React Native too. There are accessibility hints and labels we add, but I would like for it to be a little bit more elaborate than what it is today.
For Charles and Brent, maybe let me modify the topic a little bit. How do you deal with different input devices? Because obviously for creative apps, maybe tablets or stylus, and for games, there's numerous game controllers and other input devices that you need to take into account. Does it manifest it in the application framework or framework that you use, or you have to bake that into the application?
I'll go first on that one. There have been, if there's like a predominant sort of tactile device, we will try to support those things. So Wacom tablets are very popular in illustration and motion graphics. And so I know that they have a specific SDK that we've integrated into our apps. But for the media apps, we also have to deal with microphones and web cameras and live streaming with those things. Our standpoint is being a predominantly software company. Anything with hardware just makes everything twice as difficult. And then we also have SDKs in a lot of the apps, Lightroom, the video products, the audio products, where people can write their own plugins for their whatever their device. And there's common classes. So if you're doing color correction, there's a common set of surfaces that people use in that industry. Same thing with audio, if you want to connect our products to mixing desks. So the difficulty with that is you can have touch events coming from the screen, because we support whatever those big Microsoft touch things that you see on like CNN. And then you could have events coming in from the control surface and the mouse and the keyboard all at the same time. And occasionally we'll have issues with that. And then also for illustration specifically and things like Photoshop, there's a lot of pressure sensitivity. So like if you're trying to simulate watercolor and you press down harder, the ink will bleed a little bit more in some of our brushes. And so I know that there's like specific, those were like research tech transfers for some of those things. But once you get past more than one, human computer interface, and you have to support two at the same time, you just kind of want to expand that to assume, okay, everything's here, and you need to be careful about your messaging and what's on the main thread and what's not.
Brian, what about games? I know that you need to deal with VR and AR these days.
Yeah. Well, Valorant hasn't made the jump to VR AR yet. But I think the different input devices are super challenging, right? Because you can't just translate them one-to-one, especially for a game like Valorant, which is a shooter, and you're trying to make really precise mouse movements. You can't just like, maybe there's a temptation of like, oh, maybe the controller simulates the same code as the mouse or shares a lot of the same logic. And while you do want to try to do that, at the same time, if you do that, you'll end up with a game that where the UX doesn't feel right for the platform, where you go to play the platform and you're like, I can clearly feel like this was a game that was developed for mouse and keyboard, and they just kind of bolted it onto a controller, or they bolted it onto like a mobile, touchscreen device. So for a lot of those things, you have to go back to the fundamental UX of like, okay, what is my game trying to achieve, right? And like with Valorant, it's kind of precise movements and aiming, and you're really trying to get the same feeling more than just like a direct port. So that makes it super challenging. And a framework like Unreal really helps us out in that it does provide an abstraction on top of all the input devices. So, they'll write the abstraction on top of handling all the input devices and the controller and handling the different devices. But at the end of the day, you have to, as a developer, like reimagine kind of like what the UX is going to be on this platform. And they can vary quite dramatically. You have to redo like your entire HUD, because if your fingers are on the screen covering up 30-40% of the screen, then now you have to kind of, oh well, we can't put that there because you'll never see it. So there's a lot of considerations that go into supporting different input devices, and that make it a real challenge. And I think it's similar to the multi-platform jump, where the first one's really hard, the second one gets easier, the third one gets easier, but making that leap takes a lot of thought, a lot of design beyond also just writing the code to make sure it works smoothly.
Just to close the loop on that, and I assume there are people who build casual, even serious games with React Native and Ionic. I'd like to hear your opinion, Aditi and Max, on what is the experience, what works, what doesn't work, what needs improvement.
I have honestly not ventured into something like that, so I'd like to hear from Max as well. I haven't also seen any popular apps or anything that's gaming related built in React Native. I haven't heard of any.
About games built on Ionic or Capacitor, I guess. Yeah, so I haven't seen a ton. There is one that I know. I don't know if it's popular though. It's called Cluckles, I think. It's like this chicken thing. So that's one. And then actually, of course, 2048 is a PhoneGap app. So I think it predates Ionic. I kind of forget, but there are a few of those. So I would say if you're building something that's not obviously super intensive or 3D, that's a better fit. Otherwise, you're probably just better off using an official engine, which is going to be, close to the middle anyways. So I don't think the benefit's really there.
I agree. Yeah.
Max, you mentioned about testing, and Aditi, you mentioned about developer experience, and there's a similar theme from Brandon and Charles regarding, for instance, the use of Blueprint. So this is a big thing when you pick a framework. It's not about only can you code really fast, because eventually something is going to break. We know this. We work on software engineering. Now the challenge is, how do you troubleshoot that? How do you debug that? What is the story about with respect to, let's say, end-to-end testing? What about, for instance, hot reloading? Is that useful? Is that useless? Maybe let's start from Max again, Max and Aditi, and then Charles and Brent.
Yeah, so I think my impression of testing capabilities for web apps, which would mean Ionic apps as well, is that there's actually a ton of really, really good tools out there and libraries as well. So one of the things that you see a lot in the web world is being able to write isolated component tests. So we're seeing that a lot, where you can, you write a unit test, but then you can write a visual test, even take a snapshot of what is supposed to be rendered on the screen, and actually compare the changes to the whole rendered element pretty easily. So see a lot of those. And then on the tooling side, being able to run tests in headless browsers, there's tools like Cypress, Phantom.js. I feel like we are kind of spoiled for tooling in that sense. When it comes to actually testing a final native app, that's where things get much more difficult. So obviously testing on a million different phones, especially Android phones, you pretty much need to use like a cloud service, whether that's Device Farm or something else. Being able to, I've seen some really interesting tools come out. I'm kind of blanking on the names, where they're like AI driven, quote unquote AI, everything's AI these days, but AI driven automated testing, where it will actually go through your app and kind of define like the user flows, and then bake that in and test it. So yeah, some interesting tools. I think it's still super early. I think if people are looking for a very fertile place to build new products, it's testing, it's visual testing, especially these things like AI, because we all know they're not actually using real AI under the hood. So if you actually did, that would be really interesting.
It's probably organic AI, aka human being.
Exactly.
What about on the React Native front?
So on the React Native front, we can't utilize end-to-end testing frameworks like Cypress, because it's a complete native app. So we need only mobile testing frameworks. So I noticed that component testing is really effective. And we use what's called the React Native component testing library, which is just like the React component testing library, but just for React Native. And I use something called Detox, and Detox is an end-to-end testing framework. And they're kind of between a black box and a gray box. So it's kind of a gray box test where they do have inspect your code from within. It's not entirely black box. So they try to reduce the flakiness of a regular black box test. It works out decently well. So Detox, with a combination of component testing and also unit testing using something like Jest, works out pretty well. But the real challenge with React Native or any cross-platform is the actual device, because it behaves so differently on a specific Samsung device versus another Google phone. Things would just change. Permissions may vary. The fonts may look different. All kinds of weird things happen. So we try to maximize on our devices, different device widths. We have iPads, tablets, different phones. We do things like the, device farms, where we can virtually test on those as well. So that is a real challenge. And we try to do automation as much as we can. We use something called TestFlight to push beta deployments for iOS as frequently as we can, and include beta testers to TestFlight, so they can take a look at the beta app and test pretty well. And for Android, we use Google Play to do the same, and we release beta versions before we release prod version. So that's been kind of effective to test. And also I've noticed, like with developers, we side with one device or the other. So if we tend to have an iOS personal device, we tend to test more on that and forget about Android, or the vice versa. So those are also challenges that we have to consciously overcome, and try to have multiple emulators running. And as you said, hot reloading, that definitely helps. It's called fast refresh now. It's a little better than the older hot reloading we had on React Native. And while you're developing, you catch things pretty quickly. So that really helps too.
All right, Brian, games are always peculiar, and you need to deal with quasi-unlimited game flows and numerous input devices, controllers. How do you even test them?
We use a pretty mixed approach. It is very challenging, especially because Valorant ships every 2 weeks. So at any given time, you're about 5 work days from your code going live to all players. So you can imagine that testing it's really important that it happens quickly, and that you get the feedback quickly so that you can address any issues before live day. And we do use feature toggles as well to kind of like help
Mhm.
control when new features enter the game. But everyone does their work in mainline. We don't use a branch development strategy to kind of help focus our testing efforts, which are quite expansive. We do have automated tests. There aren't many good frameworks for games out there. It's kind of still nascent in the gaming world, I think, to have really good test automation frameworks. We've developed one in-house that we use that's kind of an end-to-end functional test that can run on different devices and then give feedback. We obviously use like Sentry crash reporting as well to like make sure that any crashes that come up in development, like we fix and we're on top of right away. So the real-time nature of that's really good. But
If the game
if you
supports consoles, I don't know if Valorant support console games already. What's the difference and challenges in testing that?
Valorant doesn't currently support consoles. I'm less familiar with console development, but the general idea is that, yeah, if you're going to do console development, you get a dev kit from the console makers and you sit next to it. And they do have pretty widespread suite of remote debugging tools, but you do have to debug on the console. A lot of times for performance reasons and things like that, you're like, okay, does this specific scene or part of the game play well on this console? And it can be really hard to try to predict that. So what you end up having to do is test it again and again and again and again. And manual testing and human testing is a huge part of our testing flow. We have many internal environments that are hosting many different versions of the game at any given time with different features enabled or different content, and we kind of direct our manual testing efforts towards those things so that the humans can catch the edge cases and things like that. So having a really robust internal deployment flow that gives you the option to pinpoint your testing and get really the maximum use out of it has been really valuable to us. So.
Carbon-based testing sounds like we're going
Yeah,
back to organic AI.
Yeah, for sure. Organic AI is a huge part of Valorant's testing strategy. I think hot reloading and stuff is really powerful tool for us as well. Like our scripting layer supports hot reloading. We can even hot reload like most of the game layer C++ logic. So this helps in that local iteration phase of getting really fast. But once you get to, okay, I think, the engineer believes like, hey, my product is ready, the quality is high. It's kind of like pass it to this automation flow, pass it to this like carbon flow, and get the real feedback and iterate from there.
Charles, creative and media apps as complicated, if not even as challenging?
It has its own set of challenges. So with the video products, where there's high dependence on the hardware matrix use, different sound devices, different GPUs, multiple GPUs, how many monitors, and then also the same code base being on iOS and Android. We started using more and more vendor QE. So you pay a service, you give them very explicit test matrices. They do some Monte Carlo testing and just randomize the different things, and they actually come up with real things that you find. We have a very highly trained set of domain experts, so people that were previously film editors or colorists or audio engineers, product specialists using the app and testing for specific workflows and ergonomics. A lot of in-house automation frameworks we built. We used to have an in-house unit test framework. We've since been migrating that to Google tests, and we had some Boost tests as well and migrated those things. A lot of analytics. There's an entire wing of our company that does analytics. So, I mean, a lot of our creative apps are instrumented very heavily as well.
Fascinating. We're almost at the end, but before we close the discussion, I'd like to have each of you, since this is a topic of future cross-platform, probably pick a technology that you are confident or you bet on that's going to be important for building future cross-platform app. This time, who wants to volunteer and start first?
I'll go first because this will maybe springboard that the other panelists can shoot down and we can have some healthy controversy. I'd say, looking at apps that have withstood the test of time for 30 years plus and still going, C++ isn't going to go anywhere. And for cross-platform, we've demonstrated that we've been on every sort of surface, and you can even do certain embedded things as well. It's not going to have the numbers that it had. So, I'm hoping for the day when, like all the old Fortran engineers got pulled out of retirement because the banks didn't have anyone to fix their systems. So the banks would pay these Fortran engineers insane amounts of money just to keep their systems up. And I'm hoping that in a couple of decades, they'll need that for C++. And
Centuries, probably not decades.
Yeah. So it's not gonna have the numbers like JavaScript. Python seems to be having a very strong foothold. They've achieved pretty good performance in a lot of ways. So I see a lot of research being done in that. So for computational programming, I see that growing, at least in the near term.
C++, bet on C++. Max, Aditi, agree, disagree?
I
You can
haven't
go.
liked C++ because I started my job with C++ and, just pointers and all that was just difficult for me to comprehend, but that's a personal opinion. I do agree. It's, lasted the test of time and it could happen, but my bet is on JavaScript. And I definitely would think React Native would keep going if it's maintaining its pace, because React has been doing very well on the web side of things.
Mhm.
But I would consider anything that uses TypeScript and modern JavaScript, and trying to do hybrid cross-platform apps, just like Ionic or React Native, or even Flutter actually has come up very well, although it uses Dart, not JavaScript. But I would bet on JavaScript. And go from
What's your
there.
take on language like ClojureScript and Elm, Prescript?
I think they're all upcoming too. So yeah, why not?
It is interesting to mention, Charles, to refer to what you alluded earlier. A lot of Adobe apps and other apps such as Microsoft apps starts from the desktop, and suddenly there appear the apps on different form factor, right? Phones and tablets. And now we see the other trend where Microsoft also contributed the implementation of React Native for Mac and Windows. Now, suddenly, by betting on JavaScript, TypeScript, and React Native, you expand your coverage, right, from mobile or portable form factor to suddenly desktop. Maybe at some point it's going to be React Native for PlayStation or Xbox, and that's going to be interesting discussion that we're going to have with Brent. But first, Max, what's your take on this?
I say, why not both? I think there's obviously use cases for C++. I wish I could write C++ again. I don't think I could write a line of it that actually compiled anymore, but I always had a good time doing it. But I think in terms of technologies that I'm interested in, I have to throw out progressive web apps, only because I think we kind of took a detour with mobile. Web developers really had this kind of direct ability to build something and share it with the world. And mobile was definitely a step backwards from that, right? Like, we built something, we have to pass a bunch of hoops, we have to go through kind of a obscure bureaucratic nightmare to get the app published. And then, we're dealing with kind of forces that we have no control over. Web developers want to go back to that. They want to go back to the ability to build something and just share it with the biggest number of people in the world. And that's why I'm so excited about progressive web apps, because they kind of say, okay, we know the web couldn't do X, Y, and Z that mobile could do. We're trying to bring those things to the web and keep that freedom, that ability to publish whatever you want. And so I think for, data-driven apps, business apps, stuff that you wouldn't even need C++ for, wouldn't make sense for, I think that is just going to only grow. And we make an interesting pitch to developers who are interested in that. Like, you can build one code base with Ionic and Capacitor, which is like the native runtime layer, and it'll run on iOS and Android with the same code. It'll also run on the web with the same code generally. So we're really excited about that. It's still early, but PWAs, I'd have to say.
And note also the convergence of the web as a platform itself, right? Go, Rust, C++, C#, they all can target WebAssembly. And by that virtue, technically, you can just reuse some components written in other languages than JavaScript into your apps. Last but not least, Bran, from the game development perspective.
Yeah, I think from just looking at games, I have a hard time seeing C++ going anywhere. Like C++, it's probably going to be dominant for many decades still. I think the other cool thing to realize about C++ is like, I feel like especially in the most recent decade, C++ has evolved a lot, right? The C++ that you learned in the 80s, the 90s, or even the early 2000s, like was not the C++ that's there today. So I'm really excited to see where that goes and to see if there's going to be a flipping point for other applications where people go, hey, C++ isn't this really difficult language to master or use or do quick things with anymore. I'm interested to see if that flip takes place, but for games, like C++'s dominance will be wide. I do see a trend in the game industry towards more and more people utilizing engines. I think as we enter this like era where games are going to be on all these different platforms, the idea of like, I'm going to go make my own C++ application engine and it's going to be multi-platform and I'm going to be able to go to all these platforms is just a dying dream, especially for smaller studios. To get that access to that huge customer base, I think we're going to see more and more people trend towards using, Unreal Engine, Unity, you name it, Frostbite. And I think the smaller studios are going to be kind of forced into that to access the players, and but even larger studios, like getting the leg up on the multi-platform world, the tool set that comes with it is like really appealing. So I see future game development being more about mastery of engines and less about being a C++ wizard. But you'll always have, someone has to make the engines too. So C++ will stay dominant in that way, I think.
I have to ask this: aren't you afraid of Rust?
I think Rust is really interesting. I've looked at it. I'm actually more excited about Rust. I think it's got a lot of cool ideas, and I think that seeing Rust develop as quickly as it is, and some of those ideas filter back into the new C++ specs has been like, yeah, like somebody needs to like kick C++ in the butt to like get it to start, to start moving again. So I'm actually like a huge Rust fan. In terms of seeing it replace C++ as the engine layer, I have a hard time. I'd be excited to see the first Rust game engine come to light that can stand up to the the decades of architecture and features and support that C++ has.
All this gold,
I think. Yeah, I think that's when you go fighting against C++, that's the biggest struggle that you always have, right? Is like there's so much stuff already there. Like how do you ever catch up? But I'm excited for Rust. I don't see it replacing C++ in the next couple decades, though. No.
All right, fantastic. We're at the end of our discussion. It's a beautiful conversation, and I'm sure everyone learned a lot today. Thank you, my panelists, Charles, Aditi, Max, and Bren. Special shout out to Sentry for hosting this event. And thank you for everyone who's watching this live. Elaine, I'll give it back to you. Everyone, enjoy the rest of the event. Take care and have a good day. Bye-bye.